All right, so looking at main effects and interactions. Remember main effects? Simply tell us if there is a difference between independent variables. We are interested in the interactions, how the independent variables affect the dependent, all combined. When there are three independent variables, as in a 2 by 2 by 2 factorial design, there will be three main effects to test. Main effects are a simple overall difference that examines the effect of one independent variable averaged across the other two independent variables. So this table examines three main effects within the cell phone study. It looks at cell phone condition, driver age, and traffic condition. Drivers brake more slowly in the cell phone condition than in the control condition. Older drivers brake more slowly than younger drivers, and drivers are slower to brake in heavy traffic than in light traffic. Thus, there are main effects for cell phone condition, driver age, and traffic condition. Remember, we are interested, so this is like step one, and then we are interested in if there is an interaction. So again, in our three-way design, 2 by 2 by 2, there are three possible two-way interactions: age times traffic condition, age times cell phone condition, and cell phone condition times traffic condition. To examine each of these two-way interactions, you make three 2 by 2 tables. After computing the means, so looking at our marginal means, you look at the difference in differences. It is probably easier to graph the interaction and look for non-parallel lines. You then, again, as always, follow it up with statistical tests to look for statistical significance. So, main effects interactions from a three-way design. Are the two-way interactions different? So in the cell phone study, the three-way interaction is driver age times cell phone condition times traffic condition, so 2 by 2 by 2. If the three-way interaction is significant, it means that the two-way interaction between two of the independent variables depends on the level of the third independent variable. The difference in differences is different. Again, it is easiest to look at three-way interactions by looking at line graphs. In the top graph, there is not a three-way interaction because there's no two-way interaction on the left and no two-way interaction on the right. In the bottom graph, there is a three-way interaction because there is a crossing intersection on the left and a spreading interaction. That's what we call it when they kind of meet at a point and go in two different directions, RV. A spreading interaction on the right. The two sides show different two-way interactions, so there is a three-way interaction. If our two sides, our two two-way interactions are the same, we do not have a three-way interaction. Okay, so in the cell phone study, the three-way interaction is driver age times cell phone condition times traffic condition. If the three-way interaction is significant, again, it means the two-way interaction between two of the independent variables depends on the level of the third independent variable. Again, the difference in differences is different. So when I said that in between the two groups, the two sides, they need to be different in order for us to see if there is a three-way interaction. If you look at the top, so remember when we took our pen and moved it across from tip to tip as a straight line, and so we could tell that there was no interaction. So like right here, the variable causes yes, they're crossing, right? But the variable is causing change. Light traffic and heavy traffic almost similarly. So we're looking at the dark blue line, they're parallel. And then braking onset time, we're looking again, they're fairly parallel. So we would say no, there is not a three-way interaction here because this and this are not different. However, when we look down here, they are, there is a three-way interaction. And you may be like, that's the exact same graph. That is not the exact same graph. If you look closely, up here it's dark blue line, light blue line, horizontally-ish. Here we have our dark blue line starting up here at like 1200 milliseconds, moving down to no cell phone. Here we have our dark blue line starting about 800, and then almost moving parallel-ish in our heavy traffic condition. So this line is not parallel with this line. In addition, our light blue lines are also not parallel. So because we are seeing two interactions and they are different than each other, we can say that yes, there is a three-way interaction. Hey, buddy, it's okay. That was my dog. Why do we test these interactions? Because most outcomes are not simply main effects. They are rather interactions, and that is what we are very interested in.